All right, welcome back, everybody. Hopefully you looked at 1.1, the linear equations and the complex equations like I talked about in 1.3. Today we're starting 1.4 and we're going to do 1.4 and 1.6. 1.4 is on quadratic equations. So this is math 35. Quadratic equations. And quadratic equations come of the form ax squared plus bx plus c equals 0. I'm gonna make that a capital B just so it's a little bit easier to see, because my lowercase b's looks like 6s. The x squared part is what makes it quadratic. The most basic way to solve this is, well, not most basic. Yeah, I think it's the most basic, is using the zero property rule. If A times B equals 0, then A equals 0 or B equals 0. They also call it the zero factor rule. The only way two things multiply together to equal 0 is if one of the two things is 0. So what can we do with that? Factor them if you can. And set both equal to 0. So let's just go with an example. Let's do 10x squared plus x minus 2 equals 0. We need factors that multiply to a times c is -20, that add up to b, which is 1, which is 5 and -4. We do some grouping. We get 5x on that one with 2x plus 1. I should have another 2x plus 1 over here, which makes that a -2. We finish the factoring, we get 2x plus 1 times 5x minus 2 equals 0. Which means either 2x plus 1 equals 0 or 5x minus 2 equals 0. So this is where we do what we had in 1.1, solving the linear equations. I'll subtract the 1 from both sides. I get 2x equals -1. Divide by 2, and I get x equals -1/2. On this one, I can add 2 to both sides. I get 5x equals 2. Divide by 5, and I get x equals 2/5. So the two solutions are x equals -1/2 or x equals 2/5. Ready for some more? That's kind of, we did the factoring kind of to death a couple weeks ago. This is just adding an equals 0 and solving. So we're going to do less of the practice on this. There's plenty on the homework. There are other ways to solve a quadratic equation. For example, if x squared equals, I don't know, w, I can take the square root of both sides. And then x equals the positive square root of w, or x equals the negative square root of w. Well, let's just look at some examples. I have x squared equals 29. This just turns into x equals the square root of 29 or negative square root of 29. Yeah.
Is that where you do x equals plus or minus square root?
Yes. I could also write this as plus or minus the square root of 29. Good question. In fact, I would. I was looking at it and going, why does this bother me the way I wrote it? That's exactly why. What about x squared equals -169? Well, if I do this square root thing, what do I end up with? I've got x equals the square root plus or minus the square root of -169. The square root of 169 is 13, and the negative part makes it I. Plus or minus 13i. There's more we can do with it. It doesn't have to be nice and pretty like that. Now, we could multiply this out. Because this is really x minus 8 times x minus 8. I could multiply it out and I could get the 24 over on the other side, bring it over and try to factor and see what I get. But I don't need to. When I already have it in this form, the easier approach is just take the square root of both sides. The square root of the left is x minus 8. The square root of the right is plus or minus the square root of 24. 24 is 4 times 6. So that'll be plus or minus 2 root 6. And now if I want to get x by itself, I just add 8 to both sides. The 8 doesn't have a root with it, so I can't combine it with this. The best I can do is say 8 plus or minus 2 square root of 6. And it's important to remember that this is two answers, 8 plus 2 root 6 or 8 minus 2 root 6. So don't forget what the plus or minus means. That's pretty straightforward, not too bad, right? What is probably the most useful skill, but the hardest one to master, is called completing the square. So let's take a look at that. And the way I'm going to motivate that is I'm going to work this out the other way real quick. Let's figure out how I would have done this the other way. If I had multiplied this out, I would have had x squared minus 16x plus 64 equals 24. And I would have had x squared minus 16x plus 40 equals 0. And I would have tried to do the factor thing. And these would be the factors, and there's no way in any chance in hell that you're ever going to guess those are the factors. So this like motivates the complete the square idea. So with completing the square, what we want to do, and write ax squared minus plus bx plus c equals 0. And let's do it in this general form. Complete the square, the first thing we do is we move the c to the right. Whatever value it is. And this becomes ax squared plus bx equals negative c. And why it's called completing the square is what we do is take the b divide by 2, and square it. Add to both sides. So if I take b and I divide by 2 and I square it, I get that. So what I'm doing here, oop, these pins are in the wrong cubby holes. I got ax squared plus bx plus b over 2 squared equals, ooh, let's just stick with multicolor. Negative c plus that b over 2. Oh, fucked it up already. We want a to be 1. If a is not 1, there's another step before it. Divide by a first. And I'm dividing everything by a. The ax squared divided by a is just x squared. This is over a and this is over a. Now do the divide by 2 and square. I got all hasty. We'll just jump the gun. Here, the b over a, if I divide it by 2, it's the same thing as like really like multiplying it by 1/2. So 1/2 times b over a is b over 2a. So that's what I'm going to square, and that's what I'm going to add to both sides. Squared over 4a squared. All right, so the process of doing that makes the left side a perfect square. This is now, if you factor it, x plus b over 2a squared. I promise you. The right side, if I want to get a common denominator, I'm going to multiply this first one by 4a over 4a. And I'll get negative 4ac over 4a squared plus b squared over 4a squared. So I've got x plus b over 2a squared. I'm going to rearrange that and make it one denominator. I'm going to have b squared minus 4ac over 4a squared. And I'm going to take the square root of both sides. And I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. And I can separate that. I can do the root on top separate from the root on bottom. The square root of 4a squared is 2a. Finally, if I subtract the b over 2a over, I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And this is commonly written as just one big formula. This is called the quadratic formula. Just a second to soak that up.
I remember learning the quadratic formula, but it was never solved like this, in the sense that you never started with the exam, like the teacher never showed the work of how
Right,
and why they
they
use
didn't show you
credit.
how you get it.
Yeah.
Right? That's
Mhm.
why I did it with generic letters. I wanted you guys to see it. So let's look at some examples of completing the square without the quadratic formula. That's the derivation of it there. So let's do x squared plus 10x minus 20 equals 0 by completing the square. So what I'm going to do, this has got a 1 in front of it, so I don't need to divide by anything. I'm going to add 20 to both sides. And I'm going to leave a little room to write for when I add that completed square. Because what I want to do at this point is I want to take this 10, I want to divide it by 2 and square it. And I'm not going to write all that. What is 10 divided by 2? 5. What's 5 squared? 25. So that's what we're going to add to both sides. Whatever you did when you complete the square, whatever this value is right here in that parentheses, that's what goes right here in this. And you can factor out, if you factor out x squared plus 10x plus 25, you're gonna get x plus 5 times x plus 5. You will. This process speeds it up where you don't have to factor it. It's just that value right there. That's what goes into the square. The right side is 20 plus 25 is 50. Now we'll take the square root of both sides. I get x plus 5 equals plus or minus the square root of 45. Which is square root of 45 is 9 times 5. So this is plus or minus 3 square root of 5. Finally, we subtract the 5 from both sides. And we get x equals negative 5 plus or minus 3 square root of 5. Let me give you guys one to try. Make sure everyone's doing the right thing to start off with. We need to deal with that 4. So if you subtract the 5/4 over, you get x squared plus 3/2x equals -5/4. I'm gonna bring this 3/2 down. And I'm gonna multiply it by 1/2. That's the same as dividing by 2, and squaring it. What is that on the inside? I've got 1/2 times 3/2 is 3/4. If I square 3/4, I get 9/16. So plus 9/16. Well, I want to get a common denominator here. If I multiply this by 4/4, I'll have -20/16 plus 9/16. I can add those together. I'm going to get -11/16. Now I can take the square root of both sides there. I get x plus 3/4 equals plus or minus the square root. I'm gonna do the top separately from the bottom. Because we know that bottom is gonna be a 4. And the top is I√11. If I subtract the 3/4, I get -3/4 plus or minus square root of 11/4 times I. Or if you want to put them all in one thing, I would do -3 plus or minus I√11/4. That's x. It's ugly. It's got a radical sign in there that doesn't work to have a perfect square root. It's got I. Just because it's ugly doesn't mean it's wrong. We're gonna do that same problem, but we're gonna do it with the quadratic formula. Let's do quadratic formula. So my A is the 4. B equals 6. And C equals 5. This just requires being patient. I'm gonna do this inside in steps. This is 6 squared is 36. And 4 times 4 times 5. I think it's easier to do the 4 times 5 first. That's 20. 4 times 20 is 80. So 36 minus 80. It's gonna be negative 44. And negative 44 is the same thing as the square root of negative 4 times the square root of 11. So I get negative 6 plus or minus square root of negative 4 is 2i. And I have that square root of 11 left over. And I have an 8. So 6, 2, and 8 are all even numbers. I could factor out a 2 here. I could have this as 2 times negative 3 plus or minus I root 11 over 2 times 4. And we cross off a 2. And we get x equals negative 3 plus or minus I root 11 all over 4. Just like we got doing completing the square. So on this quadratic formula, we have that b squared minus 4ac under that root. B squared minus 4ac is called the discriminant. That word will come up more than once throughout your math career. We just showed an example where we got a negative number under there, negative 44, and we ended up with an I. If the discriminant is less than 0, we get complex solutions. If it's greater than 0, we have 2 options. It's either a perfect square why am I trying to fit this on one page? If the discriminant is greater than 0, we have 2 options. A, if it makes a perfect square, we have rational solutions. Because the square root goes away. vanishes. If it's not a perfect square, we get irrational roots. Or irrational solutions. And they have a radical in them. So an example of A. If B squared minus 4AC equals 16. Then X is going to equal negative B plus or minus 4 over 2A, whatever the B and the 2A are. There's no radical signs left. Option B, though, let's say that's bracket 17. There's no getting rid of that radical. All right, ready for a fun one? Let's find the solutions. To x cubed minus 125 equals 0. This is one of those cubic ones. This is x cubed minus 5 cubed. So if you remember the formula for this, a cubed minus b cubed, there was the first parentheses had an a and a b. Then we had a squared, ab plus b squared. And whatever sign was in here matched the first parentheses and was opposite there. So we'll apply that here, where x is a and b is 5. So I have x minus 5 times x squared plus a times b is x times 5, so plus 5x. And then plus b squared is plus 25. So I've got two things multiplied together that equal 0. They separately have to equal 0. That one gives us a nice simple x equals 5 when you add 5 to both sides. This one's a little more work. 25 doesn't factor in a way that I can do this well, so I don't want to complete the square, so I'm just going to use the quadratic formula. So I've got a equals 1, b equals 5, c equals 25. And as a reminder, we're doing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is this inside? This is square root. 5 squared is 25, and 4 times 1 times 25 is 100. So I got the square root of negative 75. Does that clean up? 75 is, I got a square root of negative 1. And I got a square root of 25 times the square root of 3. So this will be 5i root 3. So our final version is going to be x equals negative 5 plus or minus 5i root 3 all over 2, or x equals 5. Don't forget the solution up here. All right, let's look at this next section is going to be 1.6. Let me make sure everyone's got this part done. 1.6 is on other shitty equations.
Just give me a minute.
Yeah. I'm not moving the page, I'm just announcing where we're going next.
Oh, okay. Hey, sir, I do have a question. Like, the x equal 5. What is that? That one equal 5?
That comes from this part up here.
Okay, let's see. Oh, okay. I'll see.
So a good thing to know is whatever the largest exponent is. Largest exponent tells us
Larger factors.
how many solutions
Uh,
or factors.
okay.
Like if you were skilled enough, x cubed minus 125 is factor.
And oh, sorry.
We'll just do the plus version here. If you could factor that like that, you'd be a champion. That's not doable. That is not, maybe a computer could do it, could figure that shit out, those factors. But it's not factorable.
And how much like did you have like to practice to?
I'm only working backwards
Because
right
you
here.
go too
I could
fast.
never do this. I would never be able to do this. Not if you gave me the problem and 20 days, 2 years, would I ever come up with these numbers without knowing the quadratic formula? I know how to use the quadratic formula though, so I can get it pretty quick.
And is it possible for people like do very complex only with the mind?
I'm sure there are. I'm not one of them. Yeah.
When you said that the largest exponent tells you how many solutions are, and the exponent can start with 3, and you have 2 solutions, but I do this.
If you ended up with 2, you did something wrong. This one counts as 2 because of the plus or minus.
Oh, that's right.
And that's why I showed it split up right here. And we'll go in the course of this semester, we'll go into more depth of, you can look at the exponent. We can have something like x to the 6th power. We'll figure out how many roots are there, how many of them are like real roots, how many of them are radical roots or complex roots. That's later, way later. Way later. So 1.6 is on other types of equations. We're going to look at some rational equations and some radical equations. And some that look quadratic. So, rational equations. Rational means fraction. Fractions, ratios. Two things that you really want to just keep track of. A, the denominator can never equal 0. B, we can clear the fractions Or find a common denominator. Find the LCD. And make one fraction. I'm gonna show both by doing the LCD version first. And the reason why is it becomes pretty important on Thursday to not clear the fraction. So let's look at an example. Two x minus 3 over 2 plus 5x over x plus 1 equals x. I'm going to say if it has an x in the denominator, leave it alone. Don't get rid of it. Clear any other fraction. So if x is in the denominator, don't clear it. I'm just going to multiply everything by 2, which will clear that fraction. If I do that, I get 2x minus 3 plus, I distribute the 2 to both of these. 2 times 5x is 10x over x plus 1. And the right side is 2x. Now, if you can, clean up some stuff first before you get a common denominator. I've got x's on both sides, so I'm going to get all the x's on one side. I'll move everything to the left. And conveniently, the x's go away. And now if I want a common denominator, I've only got one fraction. So I can just multiply this by x plus 1 over x plus 1. And if I do that, I just get one big fraction with x plus 1 on bottom. If I distribute that -3, I get -3x minus 3 plus 10x. So if I clean that up, I get 7x minus 3 over x plus 1 equals 0. Let's make a note. Bottom cannot equal 0. X plus 1 cannot equal 0, which means x cannot equal -1. If I get x equals -1 as a solution, I have to reject it. now that I've got everything as one fraction, I can clear the fraction. So if you clear fractions, you can multiply both sides by x plus 1 if you've made a note of what goes away, what doesn't work. 'Cause if I do that, I'm just left with 7x minus 3 equals 0. And a little bit of solving is going to get you x equals 3 over 7. Which does not equal -1, so it's good to go. Let's look at the same problem, but clearing the fractions at the beginning. My denominators are 2 and x plus 1, so I'm literally going to multiply everything by 2 over x plus 1, or 2 times x plus 1, on top and bottom. No, not on bottom, just on top. What am I saying? Here, the 2's cancel. Now I get x plus 1 times 2x minus 3. On this one, the x plus 1's cancel, and I get plus 5x times 2. And nothing does anything on the right side, but it will in a second. Now we're going to get rid of parentheses. And so if I multiply everything out, I've got 2x squared minus 3x plus 2x minus 3. That's my first set of stuff. Then I've got plus 10x. And I've got 2x squared plus x on the right side. Let's gather stuff together. I've got 2x squared, and then I've got minus 3x, plus 2x would be negative 1x, plus 10x is plus 9x. And then I've got minus 3, that's all the left side. On the right side, I have 2x squared plus x. Oh, sorry. That is not 2x squared plus x. That is 2x squared plus 2x. I got a little sloppy with my parentheses. I was sloppy. If I subtract 2x squared from both sides and 2x from both sides, I can get everything on the left. And I'm left with 7x minus 3 equals 0. And that gets us back to the x equals 3 over 7. I've already noted up here, x cannot equal -1, and it didn't, so we're good. Okay. Let's kick it up a notch. And if I want to clear the fractions, so if I want to find out what the denominator can be, it might be helpful to factor anything that you can right away. So I could rewrite this as x times x minus 3. So my bottom has two terms that are different. I've got an x and I've got an x minus 3. And that's here, those are the two x's, and those are the two x minus 3s. So they show up more in one spot, but I don't need to check them in more than one spot to just make sure that they can't equal 0. X cannot equal 0, x minus 3 cannot equal 0. So that means x cannot equal positive 3. So we want to pay attention for this and this on the solutions. As it is now, it looks like the lowest common denominator is x times x minus 3. So that's what I'm going to multiply it by. Multiply by it. So I'm going to have x times x minus 3 times the x minus 5 over x minus 3 plus x times x minus 3 times the 1 over x. And we'll finally do that on the right as well. X times x minus 3. All right, so we start canceling shit. This x minus 3 cancels that x minus 3. And that first term is just x times x minus 5. On the next one, the x's cancel. And I'm left with x minus 3 times 1. Since x times x minus 3 is x squared minus 3x, both of those cancel out with the denominator there, and I'm just left with -7. A lot of work, right? So we'll get rid of the fractions and try to clean this up. X times x is x squared. And x times -5 is minus 5x. Then I have plus x minus 3. That's times 1, so that doesn't change anything. I'm going to add that -7 to both sides right now, real quick, too. So the +7 goes here, and I got a 0 there. If I clean this up, I have x squared minus 4x plus 4 equals 0. If you factor that, that is x minus 2 squared. So x equals 2 is the only solution. Okay, I'm going to go and check it. Does it equal 3 or 0? No, it's good to go. We got one more thing we can do. We can check our solution in the original answer. So everywhere I see an x, I'm going to put in a 2. I'm just trying to see if the left side equals the right side. Hopefully, yes. Here on the left side, I've got 2 minus 5 is -3. 2 minus 3 is -1. Plus 1/2. On the right side, if I clean up the bottom, I've got 4 minus 6, which is -2. So does 3 plus 1/2 equal 7/2? Yeah, that's 3 1/2. So both sides equal, and so x equals 2 is a valid answer. Is that done? Is that everything you could hope it would be? Everyone ready for the next part?
Yeah, I'm ready.
The next part is doing radical equations. And the big idea here is whatever solves P equals Q also solves P to the N equals Q to the N for N greater than 0. Which doesn't make a lot of sense when I'm saying it right now. You're like, well, how's that if I can apply to a radical? You'll see.
Sorry, can you go a little bit up? I cannot see it really well.
Sorry,
Thank you.
I had it off screen. So, x minus square root of 4x plus 12 equals 0. So I don't like the radical there. And this, what you the idea here is to isolate the radical. If you can, move it to one side. Not every example you can, we'll look at that in a second. So what that means is I will add the square root of 4x plus 12 to both sides, and I'll get x equals 4x plus square root of 4x plus 12. Right now, the highest exponent in this equation is 1. There is only one answer. But to solve this, I'm gonna make a note of that. Only one answer. Exponent
We can
equals-
square both.
Yes, we can. That's what we're going to do. There is only one answer because the exponent equals 1. But to deal with this, I'm going to square both sides. And if I square both sides, I have x squared equals 4x plus 12. Here, the exponent is 2. It's going to have 2 answers. So we have to check them because we can only have one answer for the first one. So we have to check our answers. They both can't be it. Unless they're identical, of course, then that would work, but that's going to be unlikely. So then we're going to treat it like we would a regular equation that's in this form. We're going to collect everything on one side by subtracting the 4x and the 12. And it might take you a little bit, but you can factor it. You should get x minus 6 and x plus 2. And I get, is that right? Yeah, and if I set each of these equal to 0. I get x equals 6 or x equals -2. Since they both can't be the answer, we have to check these in the original equation. If I stick in x equals 6, I have 6 minus square root of 4 times 6 plus 12. Does that equal 0? The other one, x equals -2. I've got -2 minus the square root of 4 times -2 plus 12. Does that equal 0? Before I solve either of them, I'm going to try to think smart, do less work than I have to. One of these right away, I can tell is not going to fucking work. Does anyone know which one it is and why? Well, the negative in the right, will we know? This is going to be 4 minus 2 is -8 plus 12 is 4. I don't have a negative in the radical. It is the -2 though. I have a negative thing subtracting something else. These are two negatives basically added together. There's no way they equal 0. Does that make sense? This is negative, that's going to be negative, can't get to 0. So if one of them is going to work, it's got to be the top one. It may not work either. Don't just assume it's the correct answer. So we're going to check it. 4 times 6 is 24. So I got 6 minus the square root of 24 plus 12. That's 6 minus the square root of 36. And that's 6 minus 6, which equals 0. So yes, x equals 6 is the answer, and it's the only answer. Ready for some more? Let you finish processing that person. They can be uglier. I have two radicals here. The best I can do right now is that I can split them up. So if you have more than one radical, split them up. I'm going to add the square root of x plus 4 to both sides. Then we're going to do what we did last time. We're going to square both sides. On the left side, the square root and the square cancel, and I get 3x plus 1. The right side is a parentheses squared. This is 1 plus square root of x plus 4 times 1 plus square root of x plus 4. You cannot just square the 1 and then square the square root and say you're done deal. If we do that, we multiply that out. Clean it up a little bit, I get 1 plus 2 times the square root of x plus 4 plus x plus 4. And now I'm going to try to get the radical by itself again. So I'm going to subtract x from both sides. And I want to get all the constants out of there too. So I'm going to subtract this 1. I'm going to subtract this 4. Together, that means I subtracted 5. There's a lot going on there. So make sure you follow what's happening. I still have that 2 in front of the square root. That's not gone away. Okay. At this point, if you have a number in front of the square root, there's 2 strategies. We can either divide by it, or we can leave it the fuck alone. The time you want to divide by it is when it goes away on the other side and doesn't make fractions. Can I divide this 2x minus 4 by 2 and not end up with any fractions? Yes. I can divide by 2 and have no fractions. So let's do it. Otherwise, don't. If this was like a 3, leave it the fuck alone. Just go on to the next step. Because squaring of having fractions and when you're squaring shit gets messy and you're gonna make mistakes. So if we divide both sides by 2, what do I get on the left? I get x minus 2, right? And now I have the x plus 4 with the square root. And guess what we get to do again? We get to square it again. Again, this is x minus 2 times x minus 2. You can't just square the x and square the 2. You actually have to multiply this shit out. If you do, you're going to get x squared minus 4x plus 4. And on the right side, we get x plus 4. No falling asleep. Sorry, you wanted to.
No, I wasn't. I was just,
Resting your eyes?
Yeah.
All right, I know, it's a lot of work, right? It's tedious. I actually think the calculus, when you get to calculus and even trigonometry, the next part, pre-calc B, it's less tedious. The algebra gets pretty fucking tedious. It really does. So, calculus gets easier in a way. It's got its own difficulties, but it's at least not tedious. Usually, there's a little bit, but here we're gonna get everything on one side. I get x squared minus 3x equals 0. I can factor. And I get two answers. One answer that most people can get right away, x minus 3 equals 0. But we also have that x, or x equals 0. So we get two answers. We get x equals 0, or we get x equals 3. We can't have two answers though. So we gotta go back up here to the very first equation.
Negative 4x minus x is minus 5x.
You're right. It is minus 5x. Excellent job. That changes some of this quite a bit. Good catch. Thank you. That was going to suck if that's the right answer and I had no right answers on there. So we plug them into that original equation. The 0 one's pretty easy. If I plug in anything with a 0 goes away. I got, or an x goes away. I got square root of 1 minus square root of 4. Does that equal 1? 1 minus 2 does not equal 1. So x equals 0. Get the fuck out. Now we gotta check the next one. We've got 3 times 5 plus 1 minus 5 plus 4. With the radicals. Does that equal 1? You'll notice when I do my checks, I put question marks over them. Because I'm trying to see if they actually work, and it makes it clear to anyone looking at it later that I'm not saying this is the answer, that I'm checking something. 3 times 5 is 15, plus 1 is 16. So I got square root of 16 here. And 5 plus 4 is 9, so I got the square root of 9 here. Does that equal 1? 4 minus 3 equals 1. Yes. So x equals 5 is our only answer. Good catch. Look at another. I'm not going to finish this section today like I wanted to, but there's a lot of shit going on here and I don't want to rush. Well, here I can move it to the other side, right? I can add this cube root of x to both sides.
And then we can like that instead of square them, you can cube them. Like
Correct. Instead of squaring it, we're gonna cube it.
oh, just I remember that there was something with the odds and the evens. I don't remember what it was. Like the check. You have to check if it's an odd.
We're gonna have to check the answer every time anyways. I wouldn't worry about it too much here. The check, it's when we're checking is where we need to worry about roots and stuff. So let's just go through it and see what we get. And I subtract that over and I get minus 13x plus 6 equals 0. What multiplies to 5 times 6 and adds to negative 13? So this is 30. I could do negative 3 and negative 10. So this does factor. That's good. I really don't like stopping to use quadratic formula. Only an x comes out of the first one, so I've got 5x minus 3. The 5x minus 3 should repeat. And to get that, I need a negative 2. So we'll finish factoring it. And we set each of these equal to 0. And we get x equals 2 or x equals 3/5. All right. So which of these is going to work? Or do both work? Cube root's throwing me off a little bit. I don't know what's going to happen. So let's just start plugging shit in and see what happens. Let's check them. I had 5 times 2 squared minus 12 times 2 plus 6. And we got the cube root. I'm going to leave that mark that we use that a 1/3 exponent. And then I've got minus the cube root of 2 equals 0. The only way this is going to work is if the inside of this equals 2. So what does it equal? I've got 5 times 4 minus 24 plus 6. I've got 20 minus 24 plus 6 is 2. I've got the cube root of 2 minus the cube root of 2. That does equal 0. Let's check the x equals 3/5.
Just give me a minute. Just give me a minute. Oh.
It's still there. I'm just trying to make sure we finish this problem. We only got 5 minutes left. We're checking 3/5. Okay, that's what we're checking. This part right here is 5 times 3 times 3 over 5 times 5. Because that's a 3/5 right there. That's a 3/5 right there. I can cancel out one set of the 5s. And I'm left with 9 over 5 right there. And if I multiply the 12 times the 3, I got 36 over 5 plus 6. I need to check to see if this equals the cube root of 3/5. So I think this is a little bit more helpful if I get a common denominator. Multiply that 6 by that. And I get 9 minus 36 plus 30 over 5 cube root. Does that equal the cube root of 3 over 5? Thirty plus 9 is 39. Minus 36 is 3. We do get the cube root of 3/5 on both sides. So that's going to work. So x equals 3/5 and x equals 2 are both solutions. They both worked. So with these radicals, you gotta literally just check every answer. Sucks. A lot of work, right? All right, get the hell out. No, I mean, I'll see you guys on Thursday. Did you guys have a good 4-day weekend? Good. Yes,
Yeah, did you?
it was all right. I wasn't feeling well Wednesday or Thursday. I started feeling better Friday, and then my foot cramped up for 4 fucking days. I was hauling around the house. Get old. Get old.
Thursday is a test, so we have to be in person, right?
We're not ready for the test. No, we don't have a test on Thursday.
Okay.
Where did you get that?
I know, I was about to say, just hit me with the car. What are you talking about?
There is for the students with the support course, there's the online one, but you don't have to be in person for that.
So it says our test. And then our test.
Oh, I think maybe we do. Let me look at it. I'll email everybody.
Okay,
I might just make it do at home and do it at your own time.
but there is a test. then?
I gotta look at the syllabus.
Okay,
I don't remember what I said. I don't want to jump to an answer right now.
okay, all right.
Okay.
Thank you.
Hi, Mr. Jones,
You too?
Yeah.
can you hear me?
Yeah, I can hear you.
I just have a question, like, they talk about like the test. It's like it's due tomorrow, right?
I'm gonna look at it. I'm gonna change the due date.
Yeah, I
I have to look at it again.
I just have a question because like if we don't finish the homework in the due date, it's gonna move I mean you can still do it, right?
What do you mean?
For example, like last Wednesday, like it was the homework due the last Wednesday, I think so, right?
The homework is due tomorrow. I'm looking at it.
No, yeah, but some of the homework because like it moves to the next Wednesday. You move.
I'm looking at it.
You can check mine.
You're all in the same class. They're all due tomorrow.
Oh, all the homework is due tomorrow.
Yeah.
Oh, okay, got it. Yeah. I am almost done. So.
Okay.
Yeah.
And I'll look at extending the test. I have another class that I gotta go to though.
Yeah, I had the
Yeah.
same question. The same thing happened to me too.
Yeah.
Recheck
I-
the homework. If
I
you
was
got-
thinking. I thought that if we don't finish the homework, you move it. I thought it was happening like you accumulate it.
I
But-
moved the
but doesn't
homework because I
happen.
was behind in lecturing. You should, if you got problems where it said that you were late, just go back in and restart the homework and close it and it should update it with the right time.
Oh,
But I
okay.
really gotta go. I got another class.
Okay, it's fine. No, it's fine.